All right, this is a key to topic 30, part A, and that's where we were talking about, in topic 30, we were talking about going from exponentials to logarithms and from log expressions to exponential expressions. So remember, in the lessons, you saw that if you have an expression that's written in exponential form, so you have some base raised to a power equal some number, so let's say b to the x equal y, you can always convert an exponential expression to a logarithmic expression. So you're going to say the log. Now the log always has a base, and that the base of the log is the base of the exponential. So that becomes the base. Now you got to make sure it looks like a subscript. So it's got to look like a base, like the subscript. So you're going to, and then you're going to take the log of, so it'll be the log of this side. So they see the log of y, so that we call that the argument. So the log of the argument, base b, equals, and then on this side, your exponent. So whatever the exponent is going to be on the other side of the log expression. Okay? All right, so in number 1, so let's look at number 1. So in 1a, you have the log base b of 81 equal 4. So you want to change this log expression equation to an exponential form. So remember, in exponential form, the base of the log is the base of the exponential. So it's very easy to change from log to exponential. So to exponential, so you're going to say the base raised to the exponent. That exponent you see here is what's on the other side of the equal sign. So that's going to be, in this case, 4. So b to the 4 equal, and then the argument goes here. So that's your answer. So b to the 4th equal 81. So b to the 4th equal 81. The next one, in letter B, you have 9 equals the log base 2 of m. So again, always start with the base. The base is 2, so put that first. So you can say 2 to this power, so that's always your exponent of your exponential. So 2 to the 9th equal, and your argument is going to equal that. So the answer is 2 to the 9th equals m. So 2 to the 9th equals m. All right. Now in this case, you're going from exponential to logarithm. So you're going from here to here. So in 2a, you have 4 to the 3rd equals x. All right, so you're going to write the log first because you want to change that to logarithm. The base of the log is this base here. So you're going to write as a subscript, though. Make it look like a subscript. And then the argument that goes here is this right here. So that's x. And on the other side is always your exponent. And so that's your log form. So this exponential form is equivalent to this log form. And it kind of makes sense because if you go back, you're going to say 4 to the 3rd equal x. 4 to the 3rd equal x. 4 to the 3rd equal x. All right, so that will be the log base 4 of x equal 3. So the log of x base 4, or the log base 4 of x equal 3. All right, in letter B, you have 7 to the x equal 49. All right, so again, you want to change that to a log. So always write log first. So the base of this log is going to be this base here, the exponential. So make it look like a subscript. And then, so remember, you're going to have equal signs. You have to put an argument here. So remember, 7 to a power. So 7 to a power, so that x goes here. So that means that this 49 has to be your argument. So notice the log 49 is on the same level. This was lined paper. See how it's horizontal with each other? And then your 7 is your base. Log of x, your 4 is your base. Okay? So make sure it looks like a base, the 4 and the 7. So you're going to say log of 49 base 7 equal x. All right, now in number 3, you want to evaluate each expression without using a calculator. All right, so let's look at 3a. So in 3a, we have the log base 7 of 343. All right, now, so all of these are log expressions, and you want to find out what that's equal to. So what you may want to do is convert each of these to an exponential form. And so the way I would do this is since I'm trying to figure out what that is, I'm just going to put a little box there. And so if I change this to exponential, you're asking yourself 7 to what power, 7 to the box, is going to equal 343. All right, and Now, obviously there, it's going to take a little longer for you to figure out what that is, right? So you're going to say 7 times 7 is 49, right? He did say without a calculator. So 7 times 7 is 49. And then if I do 49 times 7, so 9 times 7 is what, 63? And then 7 times 4 is 28, plus 6 is 34. So there you go. So the answer is 7 to the third power. So 7 to the third equals 343. So your answer is 3 there. So in letter A, the answer is 3. In letter B, here's what you have. You have the log base 6, that's a 6, of the square root of 6. Now what I would do first, remember we're trying to figure out what it is. What I would do first, though, is rewrite the square root of 6 as this. So the log base 6 of 6 to the 1/2 power. Because remember, the square root of 6 as an exponent is 6 to the 1/2. Those mean the same thing. All right. So let's change this to exponential. So 6 to the box equal the argument, which is 6 to the 1/2 power. Well, remember, the bases are the same, so that means that these arguments have to be, the exponents have to be the same. So your box has to equal 1/2. So the answer is 1/2. All right, so 6 to the 1/2 power equals the square root of 6. So 1/2. Letter C. So in letter C, we have this. So we have the log base 27 of 3. All right, so that you're trying to find. So I'm going to go ahead and put a box there. So I'm asking myself, 27 to what power? 27 to what power is 3? Well, let's think about that. So notice that since I'm going from 27 to a smaller number, that I'm going to be taking something like the square root, cube root, fourth root, and things like that. Okay. So I know this. I know that the cube root of 27 is 3, right? You agree? So this right here, so this 3, so think of it this way. So this 3 right here is the same thing as saying the cube root of 27. So you see that 27 there, 27? And I know that cube root of 27 I can write as 27 to 1/3. So now look at this. So 27 to the box equals 27 to the 1/3. So that means that this box has to equal 1/3. So the answer here is 1/3. So 27 to the 1/3 power equals 3. All right, so 27 to 1/3 power equals 3. So the answer there is 1/3. In letter D, you have the log base 7 of 1 divided by 7. All right, so let's think about that. So you're trying to figure out what that is without using the calculator. So I know that if I change this to exponential, this is going to be 7 to the box equal 1/7. Okay? Now, I know this from previous courses. I know that 1 divided by 7 means the same thing as 7 to the -1 power. And now look at this. So 7 to the box equals 7 to the -1. So since the bases are the same, that means that these exponents have to be equal. So that means that this box has to equal -1. So 7 to the -1 is 1/7. So the answer here is -1. Letter E, you have the log base 5 of 5. All right, so again, we're going to change this to exponential. Change it to exponential. So you're trying to figure out what this is. So I'm going to say 5 to the box equals the argument, which is 5. Now notice this one's easy because already the base is the same, so that means that this exponent has to equal this exponent. Well, that's a 1 right here, right? That's a 1. So that means that this right here, this box, has to equal 1. So 5, the log of 5 base 5, or the log base 5 of 5, is 1. That's your answer, 1. In letter F, you have the log base 3 of 3 to the 4th power. So again, without using a calculator, let's figure out what this is. Let's see what this is equal to. So changing this to an exponential form, I get the base, which is 3 raised to the box, equals the argument, which is 3 to the 4th. And again, this one's easy as well. The base is already the same, so that means the exponents have to be equal. So this box here has to equal 4. So the log of 3 to the 4th, base 3, is equal to 4. All right? And so that is the key to worksheet topic 30, part